Hey everyone, welcome back. It's going to be an interesting couple of weeks. I know everyone's having questions and issues, so I'm going to try to make this as painless as possible. So we're starting with Unit 7. It's Section 7.1, Square Root Property and Completing the Square. For example, there's a rule that says that for every real number k, if x squared equals k, then we can say that x is equal to the square root of k or x is equal to the negative square root of k. We're going to start with example 1 that says 3x squared plus 75 equal to 0. Remember back in our earlier days, we would say isolate the variable by itself, so we're going to subtract the 75 over. And we become 3x squared equals negative 75. You always want to make sure that the variable is isolated, so we're going to divide both sides by 3. And we end up with x squared equals negative 25. So, in order to solve for x, like the rule says, we can take the square root of both sides. Now notice that when we take the square root of both sides here, we have a negative in the radical. Remember our rules of imaginary numbers and complex. So isolate it as positive 25 and then radical negative 1. And we know by definition that I is equivalent to the square root of negative 1. So our result is x equals positive and negative 5i. Our next example is going to be example 2. It says parentheses w plus 3 close power of 2 equal to 20. So pretty much it's already isolated, and we're going to apply the square root property that says take the square root of both sides. Remember, if we're taking the square root of a radical, the index that we don't see, which is a 2, and the power of 2 cancels each other out, and you end up with w plus 3 equaling positive and negative radical 20. Square root of 20, don't make it a decimal. Factor it out to be a perfect number and a not perfect number. So we're going to write w plus 3 equals positive and negative square root of 4 and square root of 5. The reason I use 4 and 5 is 4 is a perfect number which we can break out. We become w plus 3 equaling positive and negative 2 radical 5. The only thing you need to do to finish your problem is subtract the 3 over to leave the variable by itself. So you're going to subtract 3 to both sides, and your result is w equals negative 3 positive and negative 2 radical 5. You're probably wondering why we were doing that. Well, the next section is called completing the square. So in order to do completing the square, you have to make sure that your equation is in standard quadratic form of ax squared plus bx plus c that we learned back in chapter 4. Then you need to find the missing c value, or basically it could be any variable used other than a or b. Most books use the letter c, some might use a letter n, some might use the letter k, for example. So the first thing you need to do is you're going to take the value of the b and divide it by 2, then square both the results. So in example 3, it's broken into 4 pieces. So the first example, example 3a, says x squared plus 12x plus c. So in order to make this problem become completing the square to resemble example 2, first thing we need to do is find what the c value is going to be. So you're going to take the b value, which in this instance b value is 12. The b is equal to 12. You're going to divide 12 by 2 and you get 6. And then you are going to square your number and you get 36. You're going to rewrite your problem using 36 for the c value. So you're going to have x squared plus 12x plus 36. Once in this format of quadratic form, think back to your perfect numbers, perfect square trinomials also. You're going to collapse it to a power of 2. The square root of 36 is a 6, so that's why it goes into the back end of the parabola, back end of the parentheses. And then you're going to take your variable x squared and you're just going to write a plain x. The sign of the middle value is going to be the sign of the middle. Since it's a positive 12, I'm going to put a plus sign in the middle. And now we're set up to completing the square. I want you guys to try b. I'm going to pause the video right now. If you worked the problem exactly like part A, the first thing you would have done is identified your b value. Your b value should have been negative 26. After you take the negative 26, you're going to take half of the value. It makes it negative 13, and squared becomes 169. So you're going to rewrite your problem as x squared minus 26x plus 169. And then you are going to collapse your problem. So you're taking the square root of 169, and that makes it 13. The sign in the middle is a negative. That's why it's a minus sign, and you bring your x. Now you guys know me. I don't make things easy for you. When I want to give you guys fractions or decimals, you are going to get them. So example C says x squared plus 11x plus c. When you find your b value, the b value happens to be 11. Well, 11 divided by 2 is still 11 divided by 2. Do not take the answer and make it a decimal. You're going to take square both sides, and you get 121 over 4. So you're going to rewrite your problem to say x squared plus 11x plus 121 over 4, and then collapse it. Because we squared this value on the end, which is 121 over 4. Well, the square root of 121 is 11, square root of 4 is 2. So you write 11 over 2. You bring your x, the sign in the middle is a positive sign, and it becomes a plus sign. Now, I gave you a fraction in the middle piece for the b value and d, so we'll work that one together. So on this one, b is equal to negative 4 over 7, which then you have to divide by 2. So remember the rules of a fraction divided by a fraction. I made the 2 a whole number, 2 over 1, so I have a fraction over a fraction. You can do your ear piece, which means the outside two numbers multiply to become the numerator. The inside two numbers multiply to become your denominator. So we end up with negative 4 times 1 over 7 times 2, which you then would square. So we have negative 4 over 14 squared. Before you square the numbers, notice that both numbers inside are even numbers. First, simplify. So we get negative 2 over 7, and then square it, which becomes 4 over 49. Now you may rewrite your equation. So it becomes x squared minus 4 over 7x plus 4 over 49. Then collapse your answer. Square root of 4 is a 2, square root of 49 is a 7. So I write 2 over 7. The sign in the middle is a minus, and then you bring your x. Okay, the reason we've been doing the last couple examples is because we need, in order to solve quadratic equations by completing the square, if you don't have the problem correctly set up, the first thing you need to do for step 1 is divide both sides by the leading coefficient, the a value, to make that the a is a value of 1. The second step, you need to isolate the variables to the left side of the equation. Step 3 is you're going to complete the square. So for example, refer to example 3. Step 4 is you're going to apply the square root property to solve for the value of x or whichever variable it is given. For example, refer to examples 1 and 2. Okay, welcome back. Example 4. The problem says 2m squared plus 10m equal to 3. Later on in this unit, for unit 7.5, we have to use the vertex form. So for right now, that's going to be a little bit different. So completing the square for this situation, in this problem, first thing it said was to divide all the problems by the value of the 2, because 2 happens to be our a value, so that the leading coefficient is a 1. So when you divide everything by 2, you end up with m squared plus 5m. I'm going to put a blank in, 3 over 2, and I'm going to put a blank on the other side. The blanks represent the c value. So think of an airplane that has 2 wings. The body's in the middle. In order to do balancing the equation, whatever you do to the left side of the equation, you must do to the right side. In your chemistry classes, when you're balancing an equation, your molarities, you need to do what you do to the left has to equal the one on the right. So in here's our setup. Now we're going to be in the process of completing the square. So that blank happens to be the c value we had earlier. So you're going to do 5 divided by 2 and then square it, and you become 25 over 4. 25 over 4 is what you're going to add to the left and right side of the equation. So 25 over 4 here, 25 over 4 on the right. The left side of the equation is going to collapse to become the parentheses power of 2. And then remember, it's what you took to get there. So the square root of 25 is 5, square root of 4 is 2. So I'm going to write 5 over 2. The variable is an m. The sign in the middle is a plus sign, so I have a plus sign on the left. On the right side, we have a fraction plus another fraction. But the rule says in order for you to add fractions, Add or subtract fractions, common denominator is required. So the denominator has to become a 4. So I'm going to put a base of 4 and a base of 4. The second fraction is already a denominator of 4. The right side, first one, is not. So in order to get a 4, you had to multiply the 2 to top and bottom, and we become a 6 over 4. Bring down the left side of the equation exactly as is. So we have m plus 5 over 2 squared. Now, since the denominators are the same, we can combine our numerators. So 6 plus the 25 is 31 over 4. In the directions it said, once you get to here to solve for the variable, you're going to apply the rules and refer to examples 1 and 2. Well, square root property. We're going to take the square root of both sides. So you're going to take the square root of the left, top, and bottom. So we become m plus 5 over 2 equals, remember, when you take the square root of an equation, it causes a plus and minus situation to occur. We cannot take the square root of 31, but we can take the square root of 4 and it becomes a 2. The last step is to bring the fraction over to isolate the variable. So we're subtracting 5 over 2 to the left side, left and right. So your final answer is m equals negative 5 over 2 plus and minus the square root of 31 over 2. Example 5. It says 2x parentheses 2x minus 10 equals negative 30 plus 6x. First thing you have to do is create the equation to become into quadratic form. So first thing we need to do is the distributive property. And we become 4x squared minus 20x equals negative 30 plus 6x. First, the next step is to need to isolate your variables. So anything that has x variables need to go to the left side. So I'm going to subtract the 6x over. Now we're going to apply step 1. So we did step 2 first to get our variables together. Before we can do step 1 is divide everything by the leading coefficient. So we're going to divide everything by 4 now. So then we become x squared minus, I'm going to reduce my fraction. So it's going to be 13 over x, 13 over 2 with an x. Put my blank. I'm reducing my fraction, so I become negative 15 over 2, and I'm adding my blank. So now we have a fraction here. So we have 13 over 2. 13 over 2, and then you need to divide that by 2. So I wrote it as 2 over 1. Numerator, denominator. So we get 13 over 4 that we are now squaring. And we get 169 over 16. 169 over 16 is what we're adding to the left and right. Once you're here at this point, remember you need to collapse this down to a power of 2. So in order to get our back end, remember the square root of 169 is 13. The square root of 16 is a 4. The sign in the middle is a minus sign, and the variable is an x. So that's the left side of the equation. The right side of the equation, though, denominators are not the same. So we need to find a common denominator. So 2 and 16, I'm going to go with a 16. Second fraction stays as is. The first fraction, for 2 to become a 16, you had to multiply the numerator and denominator by 8. And we get negative 120 for the top value. Bring down the left side of the equation. And now combine your two fractions. I'm short $120, but I found $169. I have $49 over 16. Now we can apply the square root property. So you're going to take the square root of both sides, numerator and denominator. So you get x minus 13 over 4 equals 7 over 4. Do not forget that you have a plus minus situation here. It's always going to be plus minus. Bring the 13 over 4 over the bridge. So I'm going to add 13 over 4 to the left and right. So x is going to be, I'm going to write 13 over 4 plus 7 over 4, comma, 13 over 4, minus 7 over 4. The reason for the breakdown is because we have a plus minus situation, which means we're going to add the new fractions together and we're going to subtract the fractions. 13 plus 7 makes it 20 over 4. 13 minus 7 is 6 over 4, and then reduce. So x is equal to 20 divided by 4 is a 5. 6 divided by 4 is 3 over 2. Thanks for hanging on so far, guys. It's different when you're trying to record yourself doing these examples. And if you think about it, I've only spent 15 minutes so far explaining them, where in a class setting, it could take me 45. So last example, example 6, it says ignoring air resistance, the distance d in meters that an object falls in t seconds is given by the equation, and they gave us an equation. D equal to 4.9 t squared, where t is greater than or equal to 0. Remember, anytime they give you equations like these are known as literal equations. You can take any literal equation as long as it has 2 or more variables and solve for a specific variable. So for example, part A, it wants us to solve for t, and we're not rationalizing the denominator. I know that we just finished a unit where you cannot leave a square root in the bottom, but for this problem, we will. So you're going to take your original equation. It says d equals 4.9 t squared. I want to write a mirror image of the problem. Because it wants us to solve for t, think of a mirror sitting here in front of you, and you're flipping the problem around. So it's still positive 4.9 with the t squared, and it's still equaling a positive d. Makes it easier so that you know that the variable you want at the end is on the side that you want it on. Second step is divide both sides by 4.9. So you end up with t squared equaling d over 4.9. The last step is take the square root of both sides because you want t value by itself. So t is equal to positive and negative square root d over 4.9. Now, since time is a unit of measurement, you're only using the plus side. So t is equal to the square root d over 4.9. That is the equation we're going to use. Now, part B says, determine the time required for an object to fall 500 meters, and then round your answer to the nearest second. So we're taking the equation we had here, and we're going to write it down. You're going to substitute in the d value with the number 500. So we have t equals square root of 500 over 4.9. First thing I would do is suggest taking the square root of the inside, dividing the inside first. So you end up with t equals 500 divided by 4.9 gives a square root of 500. It's going to be 102.04. Then take the square root of your answer.